All right. Well, thanks for showing up. My name's Dale Rowe. This is Scott Pack. We're going to talk to you a little bit about a project we've had going on for a while. A lot of people are doing stuff with drones. Can you hear me? Is it the accents or the level?
Can you hear it at all?
Okay, if I talk really loud, can you hear me? Okay.
I don't think the microphone's working.
Dale. This is Scott. The microphone apparently is recording, so we're not being obnoxious, we just can't use it for that. We've had a project going on for a few years, looking at kind of different things quadcopters can do. Scott is somewhat of an expert in the area, and I'm kind of his supervisor. I can't go on to the introductions. I teach IT at BYU, and when I say IT, I kind of mean the fun stuff that I like teaching. I kind of try and stay away from the areas I don't like, but I teach penetration testing and forensics and a couple of the fun stuff like that. I've been there for about 4 years, so my accent is just on the point of kind of not being British, not being native, and I don't know where it's at. If you don't understand me, please just stop me and ask a question, and I'll try and answer it. I worked a bit in the aerospace industry for kind of doing security and different things there that I'm not really supposed to talk too much about. Scott was one of our grad students at BYU and came up with this really cool idea of using a quadcopter to try and map out networks. And so he's going to be kind of running through some of the background on that. He now works for Adobe as a security analyst. Probably earns more than I do, which is great. That means I was successful somewhat in helping him get that. And do you want to kind of pass on?
Sure. Are we just going to go to the next?
Yeah.
All right. So, short experience that I had just coming into the other Las Vegas security conference. I was on the tram. I've been going back and forth between New York and Mandalay Bay like 4 times a day. One time I sat down next to a guy, and he said, "Oh, are you here for that security computer thing here?" And I said, "Yeah, that's what I'm here for." He then told me a little bit about how his son works for a large government security contractor and how big the industry was. And then he said something that really surprised me. He said, "Yeah, I don't think it's going to last too much longer. I think this whole security thing is just going to blow over." And that like kind of blew me away. Like everything I know about the security industry, like malware variants are skyrocketing. We're seeing more every day. We're seeing governments and companies pouring hundreds of millions of dollars, billions of dollars in some cases, into doing security research and operations. Like I don't see where this guy's coming from. So I asked him, why do you think this is going to like start tapering off or anything? And he answers, well, it's robots. Like robots are going to end all of our security problems. So I wish I could be presenting something like a robot that was going to be fixing all of the security problems today. But we do have a couple ideas about how we can use mechatronic systems, specifically a quadcopter, in making some of our jobs a little bit easier, either as an attacker or as a defender. So a little bit of history, some from Defcon, some elsewhere, into this space, the kind of the combination between robotic aerial platforms and wireless. Chris Anderson with 3DR a couple years ago presented a flight controller called the ArduPilot, or the APM. Very, very cool flight controller, incredibly flexible. I'll be talking a little bit more about that later. And then Mike Tassi and Rich Perkins, I think this was 2 years ago, both at Black Hat and here at DEFCON, presented the WASP, the Wireless Aerial Surveillance Platform. And this was a repurposed military drone that could do a lot of really cool things. Everything from setting up basically a flying GSM and cell tower to mount in the middle of your phone calls, do aerial surveillance and attack. It was VPN to a base station so that you could control both the flight of the platform and its offensive operations from the ground. It was incredible how much they fit onto this 14-pound military drone. And then just last year, Ricky Hill did some work in using the commercial DJI drone. What's the one called again? You've got 2 of them.
Oh, the little Parrot AR drone.
The Parrot AR. No, it wasn't the Parrot AR. It was the DJI Phantom, to basically do a flyby of a beach and do some kind of like low-resolution war flying. So we also strapped a wireless pineapple on here. If you've been in this room for more than about half an hour, I'm sure you've heard of the pineapple. To do everything that you can do from a pineapple anywhere that a drone can get, which is, if you've done any amount of RC flight, pretty much anywhere. So outside of Defcon, though, there's been a lot of cool stuff happening as well. These two guys, Theodore Reed and Joseph Geis, I think it's out of Stevens Institute of Technology, they did some work in using a drone to provide a covert transmission channel. So if you're a network administrator or anything, basically your knowledge is coming from your egress, your network egress. And if you're trying to do something to stop command and control traffic, that's where you have some amount of power. You can put in firewalls, you can put an IDS in place, but if all of a sudden your endpoints are communicating with a drone that's sitting on your roof or on your balcony, you don't have control over that network egress anymore. So that was a lot of what these guys did in setting up a proof of concept to do command and control over an alternate transmission channel. The ANT catalog is a little bit more of a touchy subject, I guess. If you're familiar with what the ANT catalog is, you know who published it. And the Sparrow 2 is pretty nondescript in what they're in their documentation, but it's pretty easy to infer that it was used for probably both offensive and defensive operations on an airborne platform. So cool stuff going on in the field. And although it's not really an advance of the art here, I figure this is Defcon. What's a presentation without a cat in it, right? So this is Orville Copter. I believe it was an artist out of Finland taxidermied his cat and put it on a quad. But that's really not here nor there.
Really, you wouldn't want to do that.
Yep. So I'm going to describe a little bit about what goes into building a quadcopter, and then how we're using a quadcopter in our situation to do wireless mapping, heat mapping. So pretty much every quad you're going to see, it could have a wide variety of different frames. You've got Y3s, which is just like a single quadcopter, not even quadcopter, a tricopter, 3 motors. You can have a Y6, which has them up and down, gets a little bit of redundancy on the motors. You get quadcopters with 4, hexacopters, octocopters, they go crazy. Lady Gaga actually had a dress built that was like powered by quadcopters, so she'd stand on this thing and fly around. But really, like, there's tons of different frames. What you choose as your frame, the material that you use for it.
Speak a little bit louder.
Is this? Can we use?
That's not. It's for the recording.
Okay.
The videos. It's not. There's no speaker.
All right. Okay, I'll try. The material that your frame is built out of and the way that it's set up will have a lot to do with how it's actually going to feel in the air. If it's a little bit more of a little bit of a flexible frame, it's going to feel a little squishy, but it's also not going to have as much vibration from your motor. So there's some trade-offs when you're looking at frame materials. For power, pretty much every quad I've seen uses lithium polymer batteries, very high discharge rates, pretty good capacity, very lightweight. There's been some really cool battery advancements over the last, even in the last just couple of weeks, that could lead some way for some lighter weight, higher capacity batteries. So it'll be interesting to see what happens in that field in the upcoming months and years. As far as motors, they're brushless motors, controlled using an ESC, which is a small microcontroller. And again, used between 3 and 8. The propellers, these things are sharp, and they're very fast, but usually between 8 and 12 inches end to end. ESC I mentioned. So on a quadcopter, in order for it to make it flyable, there's an input loop, and it will pull a number of different sensors on a couple of different frequencies. Uses magnetometer for determining your heading. That's what prevents you from kind of getting a corkscrew effect when you're up in the air. Barometer is used to determine the altitude of the quadcopter. Accelerometer to determine the absolute angle, the angle of attack that it's currently at. Gyro to determine rate of change, and then GPS. Not every quadcopter is going to have a GPS on it or a sonic rangefinder. Those are kind of just additional nice-to-haves that open up a lot more functionality and lets you do a lot more cool things with it. communications to it. Most quadcopters are controlled using a 2.4 gigahertz transmitter. Sorry, go ahead.
Louder.
Louder still. Holy crap. All right, and then telemetry. If you want real-time results back from your quad, you can also put an additional radio on there. Sometimes we'll be using Zigbee. There's a number of different alternatives here to get in-flight stats back to your ground station. So this is the APM 2.5 that 3DR builds. It's an open source hardware, open source software. There's a fantastic ground station for this, great mission planning. This is the same flight controller that WASP used. So for my purposes, I definitely wanted to offload as much of the work that had already been done as possible. Picked up one of these, and it was fantastic to work with. Number of different flight modes. Even if you get one of these things, it does a lot of things for you, but as I mentioned, every frame's a little different. So when you first start building one, you're going to have to do some tuning. And that tuning is going to depend on what your motors are like, what your weight is like, your center of gravity, your frame composition. But it's an open enough platform that with a little bit of work, you can get a pretty stable quad no matter what you're using. So a quadcopter minus the frame pretty much looks like this. The battery is used to power the ESCs. The ESCs typically have a battery eliminator circuit in them, which can let you power your flight controller. Flight controller is hooked into your receiver, which you're sending controls to with your transmitter. And yeah, typically the flight control board will integrate a large number of your sensors. Sometimes you'll have additional ones that come off, an off-board magnetometer or a GPS. But yeah, that's basically the electronics of what builds a quadcopter. So if you're into RC, most likely you got started flying a fixed-wing aircraft. There's a number of benefits that a rotary wing aircraft like a quadcopter has over a fixed wing. First off, VTOL, like being able to take off where you are, not needing a 100-yard long landing and takeoff strip is awesome. It lets you get places where you just can't get with a fixed wing, and it lets you be able to go basically as slow as you want to. So if you're wanting to stay in one place and take a number of readings, or like if you have a video camera that you're wanting to just perfectly line up a shot, you can't really do that on a fixed wing because you can't just stay in one place like that. Most of the quads that I've worked with have been pretty easy to repair, that being a result of like the frames. So the same way as a car, like when cars have safety testing, they're going to be building in crumple zones. And those are areas of a car where when you're in a crash, you have a lot of kinetic energy built up, and you need that to go somewhere. So with a lot of these frames, when I would have a crash or I'd run into something, almost every single time, this right there would break. And when that would break, I was overjoyed because I knew that, yeah, I was going to be 5 or 10 minutes of unscrewing stuff and like reconnecting wires here and there, but I also knew that it meant that my motor didn't get destroyed in the process. So if you're building a frame yourself, I would really encourage building a frame that is going to take the brunt of a crash when it inevitably happens. If you've flown before, you know that you spend as much time fixing your aircraft as you do flying it. So it's just kind of a fact of life.
This will happen. We've built a few of these, and every single one at some point has crashed in varying levels of severity. And it didn't take us long to figure out that if we control where it breaks, it really does save a lot of money in the long run. These things don't glide very well. They're kind of like you can buy the frame that I used was like $15 out of China. So you can replace one of the arms for like $3, but a motor is going to cost you $20 or $30, and a battery is going to cost you $40 or $50. So it's a lot easier to replace the cheaper components. That being said, there's a lot of drawbacks to a quad too. Like a quadcopter, all of the lift that you're getting out of a quad, or pretty much any kind of rotary wing aircraft, is coming from the propeller. Whereas with a fixed wing aircraft, you're pushing yourself through the air and you're generating a lot of lift. So you're using the lift from the air moving over your wing to bring you up and take care of your weight problems rather than having to expend all this energy to keep your prop spinning. So with a 5500 mAh battery on a quadcopter, even if it's a light quad, you'll be lucky to get 15 minutes of airtime out of it. With a fixed wing, you could, depending on thermals, you could be in the air for 1, 2, 3 hours.
So like the flight time really is a pretty big consideration. Quadcopters, unless you do something else, they're going to look like this, right? And it's really hard to tell if an X is upside down. It's really easy to lose orientation when you're flying one of these things. If it gets behind you, trying to remember which way is forwards, which way is backwards, it's really easy to get into a spot quickly where you don't know what you're doing, lose orientation, end up in a crash. And with these propellers going the speed they are, these things are knives. Like propellers, I've had 4 propellers in my backpack when I've been traveling for months, and not once has TSA stopped me. I don't know why like a 2-inch Swiss Army knife is contraband, but like a 4-inch, almost knife-sharp propeller isn't. But these things can be very dangerous. Like they are called on a regular basis, and for good reason, flying lawnmowers. And a lot of people have done some pretty serious damage to themselves. If you're all squeamish, if any of you are squeamish, I'd recommend like not looking at this next slide. Like
this was not
to the
us.
face.
This was not us.
To the
I
face.
just want to clarify that.
Yeah. So fortunately, none of these were a result of like my flying or anybody in our research group. These are all complements of AeroQuad, but we did have an incident where, somebody that was relatively new had taken it out and was doing some flying, and the flight controller has a safety built-in feature that when it loses, if it's in automated mode, so if it's doing self-direction and it loses telemetry, then it will return to home. So that's usually good. Like if you're flying and you're 500, 600 yards away and you lose telemetry, you want it to come back to you so that you can take control over again and land it where you want. In this situation, it lost both telemetry and a GPS lock at the same time. So it didn't know where home was, or at least the place it thought was home was not home. And unfortunately, there was somebody that didn't anticipate getting hit by a quadcopter walking back from school that day between it and where it thought home was. So ended up with this really bad scenario where there's somebody running this way, quadcopter running this way, and
Quadcopter wins.
Quadcopter wins every time. That one ended up in like over 20 stitches. So you want to be really careful with these things. Yeah, it only takes once to really mess yourself up.
Again, another reason to control the brake points, because you want your emergency response to kind of be land as fast as possible, straight down ideally, and even if it's that shutting the motors off and hitting the ground, it's better than putting kind of 20 stitches in someone's calf, which is what happened in this instance. These things are pretty lethal. Other thing, if you are going to have some kind of automatic autonomous flying capability where it's going to go from point to point, be really careful of the altitude and have a backup for your GPS. Have something like an ultrasound that's going to fire at the ground. And it's going to tell you, hey, you're 2 feet off the ground, 3 feet. If you're above 8 feet, your chances of hitting people are a lot less. So try and think about the worst possible outcomes, because they do happen, and they're not too pleasant when you're trying to pick up pieces off the ground and hand them back to, his part of your leg. Good luck with that.
This is yours.
Be good with it. So,
actually, Europe. Yeah.
So in terms of use of quadcopters, there's one big trend right now that's going on is going and taking some of these really cool videos, and the national parks have recently kind of stopped that. Someone got cited a couple of days ago in Utah for flying over a national park and a monument, and they weren't doing any harm, but just kind of got in trouble for that. So you certainly have to be a bit careful where we use these. We know the military uses them in surveillance, and we were trying to think of different types of uses that would be kind of outside the normal, something we could do that would really be useful on a really large scale, that everyone would kind of perhaps have an interest in. And initially our thought was, well, if we put some solar panels on this thing, we could fly it up on top of a building, use all the flight, kind of leave it there for a few days, and then fly it back off once it's recharged through the solar. And we were looking at that, and we started to look around. We found that people had started doing that kind of thing already. And as we were having a conversation with some people in our IT department, they mentioned one of the issues they're having with kind of mapping out where the signal strength is and rogue access points.
So 1 second. Really quick, on this right here, the United States Senate has asked the FAA to figure out what to do with this whole quadcopter thing over the next year, especially as far as a first-person flight goes. If you're at all interested in this field, I'd recommend trying to find some way to get involved in it. Write your congressman, look for petitions. This is the kind of thing that there's a small enough group of people that are interested in it, that it's really easy to just get kind of written off, and that's something that we give up without even knowing. So I'd recommend try and keep your eye on what's happening here from a legislative perspective.
So the idea of heat mapping, it's not a new one. The idea is you figure out where your wireless signals are. And if you know where your wireless signals are, there's two reasons typically you do that. One is to make sure that you've got sufficient coverage, because you want to make sure that all your user base can access the access point from the right places. And the second is to make sure that you don't have coverage in areas that you don't want coverage. And that becomes an issue when you have signals emanating quite a distance from a building. When they were doing the WASP presentation a couple of years ago, they showed that you could actually get these signals several hundred or even 1,000 feet above a building, because a lot of these access points are mounted to the ceiling, and we think that's great for dispersing the signal down, but they'll also disperse the signal up, and there's not much above buildings that'll stop that in most instances. So the idea of heat mapping in 3D is something that quadcopters are extremely capable and really well designed to do. You know, because they can get into those really small spaces outside the building, they can get kind of gullies between the building, they can get higher than the building, they can get around, they can map things out. And there are a couple of other advantages to using a quadcopter that in a few slides' time you'll kind of see what else we gain doing that. In a pen testing class, just to give you an example of the utility of this, if you haven't done it before, I require my students to go and do some war driving. And I tell them they have to be in twos, because you always get someone who'll try and hold their phone and war drive as they're driving the car. That's not good. Send them out in twos. One of them's got their phone or got their laptop with an antenna on the roof of the car, and they drive around trying to find access points. And in a few years of doing this, we found like police stations with secure criminal net records and networks being passed around on wireless networks without even using WEP. I mean, if you're really not going to know what you're doing, at least not know what you're doing and use WEP. No, I don't know. They were open. We found a courthouse that was completely open and broadcasting all the video streams around on it. We found some pretty interesting things and again, you're probably not too surprised by it, but these stories go on and they happen. I was at Black Hat 2 days ago, and my phone popped up saying, "Hey, smart Wi-Fi's just turned your Wi-Fi back on. Great. There's 131 access points near you. Which one do you want to connect to?" These things are everywhere, and being able to map them is extremely useful.
So for the equipment for doing a war driving scenario, go about, is pretty straightforward. Like everybody knows, you need your adapter, you need a laptop or something to be pulling the data and recording the data. You need an antenna, and sometimes you also have a GPS receiver on there. So when I first started trying to do a 3D site survey, I originally just started trying to use this GPS for lat long as well as altitude. But if any of you really use GPS for much, you're going to know that lat and long can be pretty accurate, but altitude on GPS is miserable. Like the first couple that I did, I'd have a range of about 50, 60 feet. And if you're trying to get an idea of where an access point is, that kind of resolution is just not acceptable. Like being 50 feet too far high or low for where you think your data point is just not good enough. So I was using a barometer. It's a BMP-085. It does not look like this. But it gave me about accuracy within a foot, 18 inches or so. So that was a lot better. And I'll be able to show you some of the results from that. As far as an antenna went, I was using one of the Alpha 036NHs. If you walk around here, you could probably see a dozen of them. Awesome antenna, really easy to use, compatible with pretty much any tool you can think of. So this is the kit all kind of Frankenstein together. I found that with all the gear on there, I was able to get about a 12-minute flight. Since I didn't want to crash it, I typically try to limit most of my flights down under 9 minutes, 8 or 9 minutes. Basically what I do is that as it was flying, the Raspberry Pi was pulling the alpha connector for RSSI, which is basically signal strength, the SSID, and the BSSID, the MAC address, as well as recording the altitude and the coordinates. So network information and then geolocation. It'd write these all to a CSV, and after the flight, I'd go over with an ugly couple of MATLAB scripts to create a KMZ out of this. So after I first assembled the whole thing, it's like, okay, I want to try something easy. I was still learning how to fly it, so I wasn't a very adept pilot. Went out to a park, took my laptop, stuck it in the middle of the park, put it in ad hoc mode, and did a flyover. And this is pretty encouraging. It told me, like, yeah, it's about what I'd expect. Higher signal strength in the middle, wanes off as you get closer to the edges. Did a perimeter flight, about what you'd expect. And basically, this kind of information you can get with Kismet, right? If you bring up Kismet and start collecting geolocation on it, you can generate these kind of maps. It started getting a little bit more interesting when I would do like just a fly around in this park with the laptop in the middle. But a problem I started running into is when you're looking at it like this, your data points are getting in the way of each other. And I was trying to figure out how to visualize this, and I took a cue from the medical field. So when you're doing an MRI or really any kind of visualization, like any kind of medical, what's it called?
Scan?
Medical scan, any kind of medical scan like that, they're typically going to slice things along at different depths. So in this case, like they use it, they go from the top of the skull down to the bottom of the skull, trying to find tumors, things that have soaked up more of your radioactive dye than other places. So cueing from that, I would take this data, interpolate it across the area, and then slice at different altitudes. So right here is a 5-meter slice, a little bit higher signal strength in the middle. As you anticipate a little bit higher, you get it lower. Well, that's kind of boring. I was feeling a little bit more comfortable as a pilot at this point, so I decided to take it on campus. This was not the incident where the student got sliced. I made sure.
We were not involved in that. Let's just be really clear.
So essentially what I did here is I flew what's called a vertically aligned lawnmower search pattern. Basically just flying it back and forth, increasing my altitude, trying to hit each floor, fly by at once, going relatively slow so I could try and get a decent amount of samples per linear foot or whatever. Yeah, over the course of this flight, the flight on this side took about 6 minutes. The flight on that side took about 3. So if any of you done any amount of war driving before, you know that it can take a long time. If you're walking around pushing a laptop on a cart, you can pretty realistically expect to spend like an hour, 2 hours walking around or inside of a building trying to collect this data. Over the course of this flight, I picked up about 350 access points. Wrote these all to disk. So after I pulled out all the data, I filtered it out on a single access point that I found out from our campus IT was sitting here in this corner, and just did contours on that one AP. So kind of as you would expect, on a high gain antenna, the further away you go, it's going to get a little bit of a donut pattern. It's not going to be like an omnidirectional sphere. So, which makes sense for the building. Like typically on every building, you're going to have an access point which is responsible for covering a quarter or half the building, depending on where it's placed. So you can tell that this is pretty much doing what you'd expect. Well, that wasn't kind of cool. Like I can do basically the same thing, again, just walking on the ground outside of the first floor. So I thought, let's pick a little bit more interesting access point. This one was on the 5th floor of the building, and campus IT had no idea what it was. So it was actually a rogue access point that some student or faculty had just turned on, plugged in, and stuck into plugged into our network somewhere. So using this map, I was able to like help the sysadmins out and basically point them to exactly where this rogue AP was. So they're able to go into the building, track down, like go almost right to the right floor, know almost exactly which room it is in, go in there and unplug it, give the faculty a smack on the hand, and they were out of there. So I mentioned before that this was kind of done using an ugly mixture of scripts. Some of it was Python, some of it was just parsing bash stuff. Some of it was like the visualization was all in MATLAB. So just for you folks here at Defcon, I've spent like the last 3 or 4 days until 2 a.m. porting all of this into Python and moving it over to a Kismet plugin. So now you should be able to pull it's available here on Git. You can pull it down, use it with Kismet, grab a Raspberry Pi, plug in a barometer, and you should be able to do these same kind of heat maps, including the interpolation. Really quickly, I'd like to show you what it looks like.
Just while he's doing that, just to kind of, the real strength of this we found was that rogue access point scan. We weren't expecting to see those kind of things. We weren't really looking for them. It was just a case of going through the list, and that kind of popped out and drew some attention, and we started looking more for it. And very, very quickly, in a 9-minute flyby where we captured 130 APs, pick out that one and localize it within the building to the point of 2 to 3 offices to look into. And 9 minutes for a building of that size is, we've got guys going around our building that take almost half a day to a day per building that size to do a full interior map of where everything is and look for roads.
So once it does the interpolation and the contour draw, it actually is writing it to a KMZ, which you can open up in Google Maps, not Google Maps, Google Earth. So once you have it, you can rotate it around and get an idea of like where is your hotspot, what's around it, what kind of context do I have, what floor is it on, and that kind of thing. Go away. Soon talk about applications.
Okay.
Yep, you're up.
Okay, great. So in terms of other applications for this, we were looking for kind of what else this could do. Rogue access points were one that we discovered. Mapping out the signal strength was one. Okay. Go back one slide. Yeah, no problem.
It'll be actually we'll have a slide at the end where it has it there too.
One of the downsides of the drone, obviously, unless you can land it somewhere, is it's not that effective for attacks. One, it tends to be fairly noisy. And I know you see these movies of the world ending when someone's sitting in their office typing quietly, and you kind of see transformers flashing by, and you have this perception that inside the office you wouldn't notice a little drone flying by. We found the opposite. It did draw a bit of attention, so they're not the most discreet devices. That said, you could probably go out at 2 a.m. in the morning and fly it, land it on top of the building, do some attacks, and then, assuming it's got enough battery, come back the next day and collect it. And we were trying to think of where to go from here, what would be useful. And the real thing that kind of stands out with a lot of the talks we've seen this year and last year is software-defined radio. It's trying to take this thing and expand the horizons of what it can do. And you can imagine a cell phone company might be quite interested in the ability to fly these things out into the desert somewhere and look at their access point strength in different canyons, or try and map out things. So with software-defined radio, you can really start to do a lot more than you would normally.
Yeah. So additionally, right now on the quad, I basically have just a low-gain omnidirectional antenna. I think it'd be really interesting to see some work go into using the same kind of platform, but putting a directional antenna on a gimbal to try and get a little bit better idea of like spearing directly in on a single AP, trying to trace it and figure out like from what angle you can get higher or lower access. Like, it'd be a ton of work. Gimbals are by no means cheap or easy to work with. But there could be some really cool stuff that could come out of research like that.
What about rotating the platform itself with a directional antenna instead of trying to...
Yep.
Or rotating the...
Yeah. You've got the accuracy to do that kind of stuff.
Yep, absolutely. So here's our contact info. If you'd like any more information about it, or you're interested in working with us on some of these other ideas that we have going on, please get in touch with us. That code, the Kismet client and the KMZ interpolator and KMZ generator available right there. A little bit more information. The full paper is actually part of my thesis research. So feel free to get in touch with us or read up more on it. Thank you. Any questions?
If there's any questions, we'll be here for a few minutes. Feel free to come up and talk to us about it. We'll do our best to answer them. Thank you.